This video is about the basic terminologies that are used in the steel design. Before going into the basic terminologies, I'll explain you why we use the steel construction. In the ancient days, we people used iron for weapon making for wars. But after that, during the last 50 years, people stopped using the iron and steel in any part of the construction or something like that. So the present days are the days of interdisciplinary approach. So people started even using steel for construction purposes. So we before using any material into construction, we should be aware of the advantages and disadvantages in that material. So the basic advantage of using steel in the structure is like better quality than the RCC and lighter in weight, and it is faster to erect and faster construction can. Take steel for construction, and less material required, and has a better ductility and have a good behavior against the lateral load application. And coming to disadvantages, there are few disadvantages in using steel structure. That are all skilled labors are required in the case of steel construction, and maintenance cost is also very high when compared with the RCC structure, and the electricity are required in the place of connections, welding connection, riveting connections, so electricity may be required. So what are the basic differences between RCC and steel construction? The RCC requires many material like cement, water, aggregates, fine aggregates. Such things will increase the expense to a greater extent. Whereas coming to steel, that cost of water and cement is not required. Thus, the 30% cost saving is in steel, and more time is required in the case of RCC, because in the case of rainy seasons, people will not work in rain with RCC, because it takes much time to harden. Whereas coming to steel, it is not at all a problem. Thus, the time is 60% lesser than the RCC, and less resistive to earthquake. Yeah, RCC is very less resistive to earthquake, and it is coming to steel, it shows a good behavior in earthquake. Different types of sections are used in the steel connections. Here are the different sections: angle section, T section, channel section, I section, solid section. Angle sections are used at the place of truss and the types of connections. And T section is also like connecting the beam and the column, such connections. And channel section and I section are used for bracings, column sections, such things. Coming to the terms used in the steel tables, so there are certain abbreviations, certain terms that are used in the steel tables. We should be aware of that before going into the design. So XX is the x-axis, and YY is the y-axis, and TF is the thickness of the flange, and TW is the thickness of the web, and H is the overall height of the section, and B is the width of the flange. We have come across the word yield stress, ultimate tensile strength, elasticity modulus in concrete. We should be also familiar with these terminologies in steel. Yield stress is nothing but the stress at which the structure fails, that is the steel fails. It is usually denoted by Fy. Fy is 220 to 540 in the case of steel, and ultimate tensile strength is the strength that is required to the maximum, that is required, that is in a steel to hold the load. And modulus of elasticity is 2 into 10 power 5 Newton per mm square, and rigidity modulus is 0.4 times of E, and Poisson's ratio is 0.3 in the case of elastic and 0.5 in the case of plastic. Classifications of connections. We are using connections in the steel connection. Like in steel structure, it is important to design the connection. The connections are basically classified into two types. One is the permanent connection, and the other is the temporary connection. Permanent connection is riveted connection and welded connection, whereas the temporary connection is the bolted connection. We say it as permanent and temporary based upon the dismantle and reuse. We cannot dismantle and reuse in the case of welding and riveting, whereas it is possible in the case of bolted. Bolted connection. In bolted connection, the leftmost part is the leftmost part of the bolt is termed as head, and next is the washer, and then is the grip length, and then is the washer, and then again the nut. Mm. So D is the dia of the bolt, and D naught is the dia of the bolt hole. And bolted connections are used in two places. One is in the lap joint and the other is the butt joint. Lap joint. What is lap joint? Lap joint is nothing but the connecting two plates overlapping the other. Like one plate overlaps the other and it is connected by means of bolted connection. Butt joint is nothing but placing two plates adjacent to each other and it is connected by means of another plate and it is bolted. That is butt joint. Riveted connection. Riveted connection can be classified into two types basically based upon the driving, how it is driven. So it is like power driven riveting is there and hand driven riveting is there. Further, power driven riveting is further classified into shop riveting and field riveting. Hand driven riveting is further classified as shop riveting and field riveting. So what is welding? Welding is the process of connecting metal pieces by means of application of the heat with or without pressure. This application of heat is nothing but fusion. So there are three types of welding. One is the fillet weld and the other is the butt weld and the other is the plug weld. Whereas the leftmost picture shows you what is fillet weld and the rightmost picture shows you the butt weld. This fillet weld is nothing but connecting two plates at right angles. That is the fillet weld. Butt weld is like 180 degree. Placing adjacent plates can be welded by means of butt weld. Definition. Before designing a connection, we should be familiar with three important terms. One is the pitch and the other is the gauge distance and the other is the edge distance. Pitch is nothing but the horizontal distance between the two rivets or bolt. This pitch maximum should be 32 T or 300 mm, whichever is minimum. So P minimum is should be greater than 2.5 D, whereas D is the diameter of the bolt and T is the thickness of the plate. Gauge distance, it is the vertical distance between the two bolt or rivet, and edge distance is nothing but the distance between the edge of the plate and the last bolt or rivet. And this E minimum should be greater than 1.7 D naught and E maximum should not be greater than 12 T epsilon, whereas epsilon is 250 by Fy to the raising to the power 1 by 2, whereas D naught is the diameter of the bolt hole and T is the thickness of the plate. Here are the notations. As I said you before, what is pitch, gauge, edge. P1 is the horizontal distance between the two bolt or rivet. It is the P1, and P2 is the vertical distance between the two rivet, that is P2, and E1, E2 is the edge distance